form a small right triangle that contains that 45. And we've lucked out here. If that's a 45-degree angle at the base, and it's a 9-degree angle to work with, right triangle, this angle here has to be also 45. It's a 45-45 right triangle. And definitely, I think almost every student would recognize there is something special about a 45-45. 30-60 you may have forgotten, which I showed you before the break. Does anyone recall what's so special about a 45-45? And back in middle school, you call this an isosceles triangle. They use the word isosceles. Yes. Two sides are equal. Two sides are the same length. So, which two sides are the same length? It's not the hypotenuse, because remember I identified the hypotenuse as 1, because that's the length of the radius. So it's not that side he's talking about, it's these two sides, which in my sketch don't look like they're the same length, but they're supposed to be the same length. What are they? I don't know yet. So we'll erase this and say, with his help, and we'll call this x and this x. He's telling me, this professor, those two sides are the same length. And then go over to the side here and apply this. Pythagorean theorem. Guys, see the hypotenuse is 1, of course, unit circle, 1 squared. The other two sides identified as A and B in the theorem. I got x squared, and the other side x squared again. That's the way it looks in the Pythagorean theorem. Or 1 is equal to combined like terms, 2x squared. Divide by 2, I'm going to do it fairly quickly. You got x squared is equal to 1/2. Now you know what has to be done next. You've got to take a square root of 1/2.
We have two rational
Hang on. And Lisa says, Professor, that looks good, but really square root 1/2, Professor, means this. That's another way to express square root 1/2. And she says, if you do, you cannot leave that radical down there. They call it rationalizing. And how can I get rid of it? Multiply the numerator, denominator by radical 2. As long as you do it to both. That now will give me a radical 4 denominator, which is merely 2, which I want. I don't want a radical down there. That's just 2. On top, of course, I got radical 2. And there now is, I've solved for x, this is x. So x here is radical 2 over 2. And with his suggestion earlier, this also is radical 2 over 2. It's an isosceles triangle. Two sides are the same length. Now I know, and you know now at this point, this has coordinates of x is radical 2 over 2, and y is radical 2 over 2 for 45 degrees. Right, found the x and the y are the same length. An isosceles right triangle. Now, if I know that, I see now where they came from. Definitely, I could ask you tons of questions. For an example, on this right here, I can now find the sine of pi over 4. And pi over 4 is the same as 45 degrees. So radius. And you said, Professor, before the break, you told us that sine's definition, brief definition, is y. It is. So if I look back, what's the y coordinate up here? Radical 2 over 2. And that's the answer I'm looking for sine of pi over 4. No problem. We'll try one more. Tan of pi over 4. Yes, I have to know my definition. And tan was y over x. Look back in your notes. And the y and the x in this case are both radical 2 over 2. So this is radical 2 over 2. That's the y over there. And the x, same thing. And that is 1. Has to be 1. So the tan of pi over 4, tan of 45 degrees, 1. Before I leave it, let's try secant. Of pi over 4, I know your definition. Secant was 1 over x. Yeah, 1 over x in this case would be 1 over, now here goes, 1 over radical 2 over 2. That's my x, oh, here it is, radical 2 over 2. Now, this one may be a little bit harder to clean up. I got it cleaned up. So it says 1, David says 1 is being divided by radical 2 over 2. That's what it says. Or better yet, 1 times, change that to multiplication, flip that over reciprocal, 2 over radical 2. I'm just doing basic math. Rationalize, multiply that by radical 2 to get rid of the radical. Right here. You gotta do it here. Gotta do it here. You guys are going to end up with 2 radical 2 on top, numerator. And what is in my denominator, the bottom part is merely what? 2.
That would be just.
And the 2's cancel.
Root 2, yeah.
Radical 2. And that's the secant of pi over 4. Secant of pi, 45 degrees. Radical 2. You can do this. Is it going to take some time? It's going to take some time. And you've got to know all those definitions. But you can definitely do it. Now, here's the question. Would I, as a professor, would I ever ask my students to do this? Sine of pi over 18. First, does anyone see pi over 18 listed on that circle there?
No.
No, it's not. Pi over 18. Now, if it will help you look at it in terms of degrees, I could easily convert this if you run to one that's a little bit tougher, and degrees may help. So here's my pi over 18, using a conversion factor that we talked about before the break. That conversion factor is what, 180 over pi. We'll quickly change that from radians into degrees. So they help to look at it in degrees.
That would be standard.
Pi's canceled. 18 goes into this 10 times. So you're looking at sine of, if you wish, put it here, 10 degrees. Have you seen me tonight mention 10 degrees?
No.
Is it on there somewhere? It's on there, but I didn't list it. Now, what I would have to find is, here goes, to find this answer, sine of pi over 18, which is the same as sine of 10 degrees, I'd have to go back, which we're not going to do, but this is what you'd have to do. You have to sketch a 10-degree angle, small angle, right in here. Squeeze it in right there, guys. 10 degrees. Drop a perpendicular, form a right triangle like we've been doing. And the other angle would be like what, 80?
80, yeah.
So you got 10, 80, right triangle. I have no remembrance of anything special about a 10, 80 right triangle.
No.
I've never seen a relationship. As much math as I've had. 45, 45, oh yes, I've seen that. 30, 60, David, I've seen that. I've never seen anything about 10, 80. I had to stop, I couldn't ask you, is there a relationship? There is one. We don't know what it is though. All the thing I could do is turn to Mr. Park. Mr. Park, here goes. And say, Mr. Park, would you please find sine of 10 degrees for me? I'd have to use a calculator. See what that is, sine of 10 degrees. What's that approximately equal to?
0.174.
174.
Mm-hmm.
Now someone stopped me on campus and asked me, Professor, what's the sine of 10 degrees? Or we're going to take all your graduate degrees back from you. All that work you've done for all these years, Professor, taking all those classes, making all those A's, we're taking all that back from you, Professor. Why? Well, you don't know what the sine of 10 degrees is. And I'd probably look at him and say, you don't either. I'd probably just look at him and say, you don't either. You don't know what sine of 10 degrees is. No way. You can't find it on your own. I'd have to use a calculator. The only ones you can find are these special ones we're talking about here. Okay, 0, 90, 180, 270, 360. You can find those. 30, 60, 45. You can find those. And some other combinations of those which I haven't done yet. But this crazy one, you could never come up with that number he just gave you from the calculator. Yes?
Isn't sine 10 also, can you also find it as the opposite side over the hypotenuse?
Yeah, but even that would require a calculator.
It's true.
Yeah, you can set it up as a triangle, and maybe you use a middle school triangle, that's what your textbook probably does in chapter 7. And use something like a hypotenuse or opposite or adjacent, how you guys learned that back in middle school. And still though, you will come up with some strange number that you would have to turn to a calculator and approximate. Now, I can't do that to you. Cannot do it to you. The ones I can do for you are those that you've seen here. Okay? Now that said, let me erase this. Guys, I've done, please help me out. I've done for 30. I did for 45, didn't I?
Yeah.
That was on the circle. Now, I am going to, now I'm not going to actually discuss this one. The special angles, here they are. Let's call this part 2. What's that part 1 now? Part 2. Here we go. The special angles. Here we go. Pi over 6, we did. Pi over 4, we did. Pi over 3, I did not do. I'll just mention what's going to happen at pi over 3. Pi over 6 is equivalent to 30 degrees. We talked about that earlier. Pi over 4 is equivalent to, in degrees, use your conversion factor, 45. Pi over 3 is 60 degrees. Now, can someone remind me right quickly, just like a recap, what was the ordered pair that you saw probably before the break associated with 30 degrees? Radical 3 over 2 with the x. You gotta know that. You gotta know the x and the y. 45 degrees, I think that's one of the easiest, which was, tell me?
Radical 2
Over
2,
Uh-huh.
comma, radical 2 over 2.
You gotta know that. And I did a discussion on that and show you where it came from. 45, 45 right triangle. I did not do 60,
But it's the
but, which is pi over 3. I said I didn't do it. I'm just give you the numbers, and I think most students may recognize this as a professor without you doing more work over here. The coordinates will come out to be these. 1/2 radical 3 over 2. It's turned around from the 30. So if you know the 30, you're going to know the 60. Without me going through another derivation, take up more time here to see where all these things came from. So those are my special angles. Now, 80. So well, hold on, Professor. Suppose you have 0. The very beginning of the unit circle. Anyone remind me what was the ordered pair we associate with at the very beginning? 1, 0. You gotta know this. If I go up to pi over 2, that's 90 degrees. There's a little recap. That's what was the ordered pair up there at pi over 2. 0, 1, you gotta know this. I think we finally went to pi, which is like 180.
Minus 1, 0.
That's what I want to hear. And we did what, 3 pi over 2?
0 minus 1.
Now here's the special angles. And that was what, 0, -1?
No.
And guys, let me squeeze on my last one. Let me squeeze it down here if you don't mind, right here. 2 pi.
0, 1.
That's one complete revolution. Let's get the complete circle, which takes me right back to 0. So what should the ordered pair be for 2 pi, which takes me right back to 0?
1 0.
Yeah, 1, 0, right back to it. If you know those, I'm happy. Those are the special angles that we have dealt with. Now, right quickly, if I'll just stand here, I'm going to play for you. If I ask you, what's the sine of, recap, the sine of 30 degrees or sine of pi over 6, you say, Professor, it's 1/2. That's the y. What's the cosine of pi over 3? Well, you say cosine, the definition was x, well, the x is also 1/2 there. If you know those definitions you saw before the break, and then connect them with these angles. David, no problem. Is it? No, there's no problem. Now, David, would I, as a professor, ask my class to find something like this? You know, pi over 17 is not one of the special angles. I have no clue myself. It exists. I just have to turn to Mr. Park in the calculator. I don't know anything about pi over 17. I could convert it, maybe, but I don't have pi over 17 on this circle, nor will I ever have pi over 17 on this circle. Okay, so guys, I could not do that to you. The only ones I can do with you on trig are these special angles. Now, as I said though, part 3, find the exact value of these. And then we are going to slow down and take a look at log. Here shortly. Find the exact value. First one, I'd like to find the sine. And I brought something in, but I'm thinking about something else as I'm standing here. It's going to be nice. I'd like to try this. Now watch carefully. Watch carefully. Sine of 13 pi over 6. Sorry, Professor, I have not seen you place a 13 pi over 6 on this circle. And you told me earlier you would never do something like pi over 17. I definitely have not seen that. But this one, I see some hands going up. At least it has connected with it a pi over 6. Not like a pi over 17, but at least has a pi over 6 connected with it. And I did discuss pi over 6. In fact, it was one of the special angles. So maybe this one I can do something with it because I see a connection to one of those others. Sine definition, remind you, sine y. I'm looking for the y coordinate. Here's the way, Professor. I don't see a 13 pi over 6 over here. You didn't show me a 13 pi over 6. I gotta find over there first. And then I'll tell you what the y coordinate is. And I'll be finished. And the answer. Lisa.
We can represent 13 pi over 6 as the sum of 12 pi over 6 and plus pi over 6.
Hang on. Lisa, look at this. Oh, she is good. She said, wait, Professor, since that pi over 6 is at least recognizable. She says, this is like a fraction, Professor. You're dividing 6 into 13 pi. That's what it says do. And I think this is 2 pi. That's 12 pi. With a remainder of how much? Pi? And I'm going to write that up here, guys, like pi over my divisor, like you did back in middle school, elementary school. She says 13 pi, Professor, could be represented as 2 pi plus pi over 6. That's the same as 13 pi over 6. Now she's going to be clever. She says, now, Lisa said, Professor, that means to move 2 pi, if you want to go back here, move 2 pi on the unit circle. Well, that would be one complete revolution. That's 2 pi. But don't stop there. Move an additional how much? Pi over 6. Does that take me right back to pi over 6, 30 degrees, that I had for my first discussion today? I'm back to pi over 6. So this is equivalent to, right here, sine of pi over 6. Now guys, can anyone remind me, that's so marked up over there, what was the y coordinate and pi, maybe it's here. Oh, I'm good. What's the y coordinate here? 1/2. So the answer is 1/2. How cute when it happens like that. I can do it. Another one here, part B. I'd like to find, let's say, cosine of, let's try it. 7 pi over 4. I don't think I listed or mentioned the 7 pi before, did I? Does it have something connected with it that I did mention? That has pi over 4 mentioned, so maybe I can do this. Now, Lisa will make her suggestion, which I thought was beautiful. She says, Professor, it's got pi over 4 in it. And I did a pi over 4. In fact, right here it is. So at least there's a connection. So why not do this, Professor? Divide this out like a fraction. Take 4 into 7. Which you go what, 1 time? Okay, so that's pi. 1 pi, make that 4 pi. With the remainder of, when you subtract, what is that, 3 pi?
Yeah.
So you're saying this plus, what was it guys, 3 pi over 4? Written like that. Please tell me I did my 3rd grade arithmetic there. Watch me mess it up. Could 7 pi over 4 be expressed as that? Pi plus 3 pi over 4 put together, is that the same as 7 pi over 4? Now, pi, here we go, I want to try to locate it. Pi, here goes, is from the beginning of the circle, 1/2 of the circle. That's pi. But don't stop there. Go how much further? What was it? Move 3 pi over 4 further. Now I've got to be careful. We're stopping right here. This is half the circle. That's pi. Now I've got to move from there an additional 3 pi over 4. I've got to be careful myself. Where is 3 pi over 4 I'm going to find? You take me into which quadrant?
Quadrant 4.
Is it quadrant 4? It's going to scoot me all the way into quadrant 4?
No.
Here goes. Do this. You guys, how much is this right here? Is that another 90 right there? Right? So I got 180, 90, that's 270. And I'm hearing some of my students say, Professor, 7 pi over 4, if you wish to convert it to degrees by using the conversion factor, which might be easier. Things do here. Pi's will cancel. 4 goes into this 45 times. As I think 7 times 45 is 315 degrees. I did put it. So we're looking at it in degrees, which might be better, 315 degrees. So I have here I go, 1 revolution, that's 360. Oh, whoa, whoa, whoa. How much did we say this was? Watch me miss this. Jumping back for pi. I got 180, half the circle, 180. Plus this little piece here, that's 90 more, that's 270. How much more do I need?
45.
45. I need to move an additional 45 degrees into that, moves me right into quadrant 4. Guys, it's right here. Now, if I can find the coordinates for that, I'll have it.
It would be negative.
Okay, thank you. Down in quadrant 4, should the x and the y be negative?
No.
Even for middle school, if you plot a point in quadrant 4, is the x and the y negative? No, the x is what, positive, and the y is negative. In fact, what numbers are they?
Radical 2 over 2.
Radical 2, positive, and negative radical 2 for the y. Oh my goodness. Are you kidding? It took me right back to the 45 degree. It took me right back, and we'll connect here. Look at this, guys. Look at those 2 triangles. See those 2 triangles? Are they congruent? They use the word congruent in geometry. Same shape, same size. It's gotta be another 45 degree angle to work with. Radical 2 over 2, negative radical 2 over 2. Finally, what was I asking to find here? Cosine, and cosine is the x. You guys, the x over there was finally, what was it? I think it was positive radical 2 over 2.
Over 2.
And that's the cosine of 7 pi over 4. Ooh. Does that make sense? So these angles that are not on that circle can now be found on that circle. Letter C. One more here. I'll slow down a little bit here. Got some concerns here. Let's try secant. Let's try a nice one here. Got 5 over 6, 5 over 4. Why not? Let's do a 5 over 3. Guys, you're going. Secant of 4 pi over 3, and remind you, secant's definition is this. 1 over x. You can't go wrong here. Now, 4 pi over 3 is not listed on that circle over there. But is the pi over 3 listed? I think there's an association. So guys, let's do this, let's divide it out. See exactly what we're doing here. And guys, I think I'm gonna end up with 3 into 4 pi, what, how much is that, pi? 1 pi? That's 3 pi, remainder of, when I subtract pi, plus pi over 3. Now, if you put those two together, that's the same as 4 pi over 3. Is that true? Now, what does that tell me to do? It says move pi half the circle, and then move from there an additional pi over 3. Now, if you like to think of degrees, how much is pi over 3? If you like to think of degrees. 60. So here we go, this last one we'll do. We'll move half the circle, pi. Boy, this circle's getting really messed up. Okay, here goes. Half the circle. And then he's telling me, don't stop there, Professor. Move an additional 60 degrees. And therefore, you're going to stop, Professor, down in quadrant 3. Hang on now. Quadrant 3. Now tell me, when I start listing the coordinates, it's down in quadrant 3. I know from middle school, and you know if you're in quadrant 3, both are negative. Whatever they are, they're negative. The x and the y if you're in quadrant 3. Can anyone tell me what should I look at to find the numbers, the coordinates? And I'll place those with those negative signs, then we can answer the question. What am I looking for? Which one? I see something on there we've already worked with that maybe I can use to list the coordinates. Samantha.
Well, you can just base it off of the quadrant it's in.
Okay, could I base it on pi over 3?
Well, you can't base it on pi over 3. It's in the,
Yeah, I know, but it's pi over 3, which I think I've listed before, where was it, right here. These are the coordinates for pi over 3, right?
well, it's gonna be the same, just.
Except they're what? They're negative.
Yeah.
It's the same numbers. Except they're negatives. Negative 1/2. Right here. Negative 1/2. Squeeze it in. And he's correct. And negative, what was it, guys, back here, pi over 3? Negative radical 3 over 2. Those are your coordinates. Must be an x and a y. Now to answer the question was find secant, which is 1 over x. So it's be 1 over, and what did the x come out to be over here? Negative 1/2. So it's 1 over negative 1/2, which comes out to be when I simplify what?
-2.
You know it's negative 2. Now I know it's negative 2. Whew. Now you wonder why our students are doing so well when they leave us? 9 students at Berkeley. And some of those students will come back. Hopefully they'll come back to campus and I can grab one of them and come to speak to you also. Michael went to UCLA. We have 9. Not just students going to Berkeley, 9 math majors. They're all in the math department. From SMC. And that's the largest ever that Berkeley has accepted from SMC in math. They've already declared their major as math. Could be applied math, just general math. Some may want to teach math. Who knows? But they're doing math. We're proud of them. So we're looking forward to hear from other students later on and go off to school. Guys, does it make sense the way we approach this? Now, I know where your mind is. Your mind is said, Professor, sure, I like the little circle, and I can follow the circle and all that business. That's no problem, Professor. Professor, could you, without going through all this, because we'll be here all night, long night, could you just maybe show me what they are? Maybe show me what it's already been done for me. You did some, Professor, show me where they came from. Oh, could I have a handout, Professor, of a so-called unit circle, and just, there they are in front of me. I brought copies in. I'll be glad circle. Now, are you gonna be able to get this and use it on your next exam? No way. No way. Oh, quiz number 8. I think we have one more quiz. Quiz number 8 will be material like this. You think you're gonna be able to use this on quiz 8? For the final exam? Not here. Not here. But I do want you to look at this. It's doing exactly what I did here. Took me an hour and a half to do it. Here it is. Okay? Now, the other side, guys, I do have a few items here to look at quite quickly with you. It's closing on chapter 4, because I know the test is on chapter 4, Wednesday. So I thought I'd do the other side of some of these items here also. Aiden, help me out. You got strength? He's wiped out. Mr. Park.
Mhm.